Question 5.3. Carbon monoxide is a poisonous gas that is present in cigarette smoke. This carbon monoxide can be absorbed into the blood where it binds with hemoglobin. We're given some information on a graph about an experiment that they've done between looking at concentration of carbon monoxide levels when there was an open window or a closed window with no smoking, smoking for 5 minutes and 5 minutes after smoking. So, following the introduction to this law, a politician stated it's dangerous to smoke when a child is in the car. Higher levels of deadly toxins can build up even on short journeys, and children breathe faster than adults, meaning they inhale more of the deadly toxins. Use the information provided and the data in Figure 7 to evaluate the politician's statement. So again, we are evaluating. We're looking for evidence that supports it and evidence against it. So we can look back at our graphs and we can see that there are higher concentrations of carbon monoxide present when there is smoking for 5 minutes and also 5 minutes after smoking. They are also significant because looking at the standard deviation bars, there is no overlap, which suggests there is significantly higher concentrations of carbon monoxide compared with not smoking with closed window, as there is no overlap. So we can see that we've got open window and closed window. There's no overlap between the two, and it is significantly higher when we look at closed window comparing no smoking to closed window after smoking. So there is a significantly higher concentration. Any increase in the amount of carbon dioxide could be dangerous because that's going to cause less oxygen to be carried in the hemoglobin if that is binding to the hemoglobin. And we can also see that there are higher levels after 5 minutes of smoking. So smoking for 5 minutes and 5 minutes after smoking, we can see there is still an increase in these levels, which supports the idea that a short journey can have an effect. However, looking at the idea against it, we know that we're roughly looking at an amount of 5 parts per million. We don't know if this is a deadly amount or if it is an amount that's going to cause harm. There's no significant difference with the open window. So when you've got the window open and the window closed, there is no significant difference because the standard deviations will overlap. So when we look at open window for no smoking and smoking for 5 minutes and 5 minutes after smoking, all 3 of these standard deviation bars overlap. So it's not a significant difference. There's no data that's been given on the child breathing rate, so we don't know how that's been affected, or the idea that children breathe faster, but they also have a smaller lung volume. So overall, they might inhale less carbon monoxide. So looking at the mark scheme, you're looking for ideas for or against. You need to have a mixture of the two. So yes, it does support the idea because they've got significantly higher correlations of carbon monoxide compared with no smoking with the closed window because there's no overlap, and any increase in carbon dioxide could be dangerous because this is the idea that the carbon monoxide causes less oxygen to be carried, which could be deadly in children. There are significantly higher levels after just 5 minutes with the closed windows, supporting the idea that even after 5 minutes, which is a short journey, it still has a significant increase. But we can also give evidence against this, and that's the idea that we don't know if the 5 ppm is deadly. There's no significant difference with the open window because the standard deviations overlap, and there's no data on the children's breathing rate.